Let us look at the next section, students. This section contains 4 questions. Each question has 4 options. These options contain matching corresponding to the entries given in list 1 and list 2. So only one of these options are correct. Okay. So let's start with question number 33. So list 1 contains different solution while list 2 contains different product or characteristics of the electrolysis. So we have to assume that there is no change in volume due to the electrolysis. So we'll start with the list 1 first. So in the P option, it is given that aqueous AgNO3 is electrolyzed and graphite electrodes are used. Okay. So if we talk about the reactions at the cathode, Ag plus will be converted into Ag, whereas at the anode, the nitrate ions will not get oxidized. Okay. So it will be water which will be converting into O2, and there will be formation of H plus. So if you look at the entries in list 2, which will be matched with option P. So we can have O2 is produced at anode. Okay. So P will be matched with 1. H2 is produced at cathode. This will not be a match. Concentration of Ag plus in solution remains the same. This will not be a match. Concentration of Cu2 plus. This is not relevant to this case. pH of the solution will change with time. This is correct, students. So 5 will be a match. So we can see that H plus ions are getting formed, and with the increase in the electrolysis, the pH will keep on decreasing. So P will be matched with 1, 5. So in the back of our heads, we can see that the answer is most likely to be A. If you look at option Q now, in the option Q we have aqueous AgNO3 and silver electrodes are used. So in Q, at the cathode, Ag plus will be converting into Ag. But if we talk about the anode, it will be Ag which is converting into Ag plus, as the oxidation potential of Ag is greater than that of water. Okay. So if you look at the options given to us, the first and the second will not be a match. Water is not getting electrolyzed at any of the cathode or anode. Concentration of Ag plus in solution remains the same. This is correct, students. The amount of Ag plus lost to form Ag at the cathode is compensated by the Ag plus from the anode. So concentration of Ag will remain constant in the solution. Fourth is again irrelevant to this case, and the pH of the solution will not change with time. So Q will be matched with only 3. We can now look at option R. So R, we have aqueous CuSO4 and graphite electrodes are used. Okay, so at the cathode, copper 2 plus will convert into copper. And if we talk about the anode, the sulfate ions, they do not get oxidized. It will be water which will get oxidized. So similarly, we have H2O converting into O2 and 2H plus. Okay. So if we look at the entries in list 2, O2 is produced at anode. This will be a match. H2 is produced at cathode. This will not be a match. Concentration of Ag plus, the option 3 is not relevant. If you look at option 4, concentration of Cu2 plus in solution does not change with time. This is incorrect, students. This will not be a match. And pH of the solution changes with time. So this will be matched with 1, 5. Now if you look at the S option now, in the S option we have aqueous CuSO4 and copper electrodes are used. So at the cathode, the Cu2 plus will convert into Cu as the previous option. Whereas if we talk about the anode now, it will be the copper anodes which is converted into Cu2 plus. So similarly, copper has a greater oxidation potential to form copper plus 2 as compared to water forming O2. So in this case as well, no O2 or H2 is produced. The concentration of Ag plus is irrelevant. If you look at option 4, concentration of Cu2 plus in solution does not change with time. This is correct, students. This will be a match. There will be a compensation happening from the Cu2 plus which is formed due to oxidation at anode. And the pH of the solution will remain constant with time. So we have the correct match, students. P will be matched with 1, 5. Q will be matched with 3. R will be matched with 1, 5. And S will be matched with 4, which is given in the A option as we had seen before. So for question number 33, the answer which has to be marked is option A. Let us look at the next question now. Question number 34. List 1 contains different cells while list 2 contains the property related to the cell that is given in list 1. Okay. So if you look at list 1 and list 2, there are 4 cells given to us, and in the list 2 some properties have been given to us. So the first and the second option are related to the primary and the secondary cell. We can first start with that. We know that Lecland cell and Mercury cell, they are both primary cells, they cannot be reused. Whereas lead storage cell and nickel cadmium cell are secondary cells, so they can be reused after charging them. Okay, so here also directly we can see that the answer will be most likely B, as no other option has correct matching of option 1 and 2 in options P, Q, R and S. So in the back of our heads we can have a tick mark at the option B. We can now solve for the individual statements 3, 4 and 5 with the cells. Okay, so if we deal with the Leclanche cell first, in the Leclanche cell, at cathode +4 oxidation state is changed to +3 oxidation state. This will be matched, students. For P, 1 and 3 will be matched, as MnO2 is converted into MnOH. So in MnOH, the Mn is in a state of +3, whereas on the left hand side it was in a state of +4. So 3 will be a match. Overall cell reaction does not involve any ion. This is not correct, students. It has ZnCl2, it has NH4Cl. So there are Zn2 plus ions, there are NH4 plus ions, and there are Cl minus ions. So fourth will not be a match. And if you look at the fifth option, during discharging, oxidation number of metal changes from 0 to +2 at anode. So students, this is also correct. At the anode we have zinc converting into zinc 2+. Okay, so fifth will also be a match. So for P, we have 1, 3 and 5. If we talk about the second cell now, students, the mercury cell, it was matched with 1, we had already seen before. The third option says that at cathode +4 oxidation state is changed to +3 oxidation state. This is incorrect, students. If we talk about the mercury cell, in the mercury cell at cathode, we have HgO. It converts into Hg. So 3 will not be a match. If we talk about the option 4, overall cell reaction does not involve any ion. This is correct, students. In the mercury cell, at the cathode, HgO converts into Hg, whereas at the anode, the zinc Hg amalgam, it converts into ZnO. So these are all the species which are present in the mercury cell. So it does not involve any ion. So we had seen that 1 was a match. So along with 1, we have to add a 4 as well. And if you look at the fifth option, during the discharging, the oxidation number of metal changes from 0 to +2 at anode. This is also correct, students. We can see that zinc changes its state from 0 to +2 at the anode. So the correct matching for option Q will be 1, 4, 5. If you look at the R option now, which is the lead storage cell, we've already seen that it is a secondary cell. If we talk about the third, fourth and the fifth option now, at the cathode, +4 oxidation state is changed to +3 oxidation state. This is incorrect, students. In the lead storage cell, there are lead present in state 0 and lead present in +4 and lead present in +2. So there is no species having oxidation state of +3. So 3 will not be a match. If we talk about the fourth option, overall cell reaction does not involve any ion. This is incorrect, students. There is H2SO4 used as electrolyte in the system. So there are H+ ions present in the system as well as sulfate ions present in the system. So 4 will not be a match, students. If we talk about the last one, during the discharging, the oxidation number of metal changes from 0 to +2 at anode. This is correct, students. At the anode, we have Pb converting into Pb2+, whereas at the cathode, we have PbO2 converting into Pb2+ again. Students, the fifth option will also be a match. So for R, we have to map 2 and 5. If you look at the last option now, which is the nickel cadmium cell. So in the nickel cadmium cell, we have NiOH whole thrice converting into NiOH whole twice at the cathode. And we have CD converting into CDO at the anode. Okay. So if you look at the matching corresponding to option S, 1 and 2 we've already matched. The third option will not be a match. If we talk about the fourth one, overall cell reaction does not involve any ion. So this is also correct, students. All of these components are solid in nature, and apart from that, there will be a water as well. So fourth will be a match. And if we talk about the last one, during discharging, oxidation number of metal changes from 0 to +2 at anode. So this is also correct, students. We can see that CD was present in a state of 0 initially, and now it is present in a state of +2. So the S option will be matched with 2, 4 and 5. Students, we can clearly see that the correct answer for this question is option B, as we had anticipated before. Okay. Let us look at the next question now. Question number 35. List 1 contains different solutions while list 2 contains various properties of the solution. So R is the universal gas constant, and we have to assume that the value of molality is equal to molarity. So the Kf and Kb have been given to us. All of these are aqueous solutions. So Kf and Kb will obviously be of water. So if we look at the list 1, there are concentration terms given to us in the form of weight by volume, whereas list 2 contains different colligative properties. So what we can do probably is we can first convert this colligative property values into the corresponding molarity or the molality value, and it is given to us that molarity and molality are both equal. So that will probably help us in solving the question quite easily. So if we talk about the list 2, we'll start by solving the colligative properties against their corresponding concentration values. So we have 500 R. So osmotic pressure is given by C into R into T. R into T. The value of T is 300. So we can see that the value of concentration will be equal to 5 by 3 in this case. So the concentration has to be 5 by 3 molar or 5 by 3 molar for the option 1. We'll just write it down. So this corresponds to molarity or molality equal to 5 by 3. Okay. If you look at the second option now, in the second option we have delta TF equal to 1.86 degrees C. So the value of Kf is also 1.86. It must mean that the molarity or molality will be both equal to 1. If you look at the third option now, so in the third option we have delta TB equal to 0.208 degrees C. So if you look at the Kb value, it is 0.52. So delta TB is equal to 0.208 should be equal to 0.52 into m. So solving for m we have 0.4. So in this case the value of molality will be equal to molarity will be equal to 0.4, students. And if you look at the fourth and the fifth options, they are just qualitatively in the ballpark of the first option, 500 R. So in this case the molarity has to be greater than 5 by 3, and in the second case it has to be of slightly lesser value than 5 by 3. Let us now look at the options which are given to us in the list 1. So P is 10% weight by volume aqueous urea solution. So in 100 ml we have 10 gram urea. So in 1000 ml we're going to have 100 gram of urea. So for option P we have 100 gram of urea present in 1 liter. So this will be equal to 5 by 3 molar. So students, for P we're going to have the correct matching as 5 by 3, which corresponds to the first option. Let us look at the second option now. So for Q we have 5.85% weight by volume. Again, if we convert it to 1000 ml, we're going to have 58.5. So 58.5 by 58.5 will give us a value of 1 molar, but the I value is 2 in this case. So students, the effective concentration or the effective molarity or molality shall be equal to 2 in this case. And for this option, we can clearly see that 4 is going to be a match. So Q will be matched with 4. If we talk about the third option now, in the R option, we have 18% weight by volume of aqueous glucose. So again, converting it into 1000 ml, we're going to have 180 grams of glucose. The molar mass of glucose is also 180. So it shall be equal to 1 molar. And the 1 molar will correspond to option 2, and it will also correspond to option 5. If we talk about the last option now, which is the S option. So in S we have 1.64% weight by volume. If we convert this to 1000 ml, we're going to have 16.4 grams of the solute. The molar mass of the solute is 164. So it will be equal to 0.1 molar. And now the I value is equal to 4. So the effective concentration for S, M effective, shall be equal to 0.1 into 4, that is equal to 0.4. So we can see that the 0.4 will be matched with the third option and it will be matched with the fifth option again. So for S, we have to map it to 3, 5. And if you look at the options which are given to us, we can clearly see that the correct matching is given in the first option. So for question number 35, the correct answer has to be marked as option A. Let us look at the next question now. Question number 36. So list 1 contains different type of cubic crystal while list 2 contains the information about these lattice. Okay. So in the option P, we have Fe3O4. So Fe3O4 has inverse spinel structure. So in the inverse spinel structure, we have Fe2 plus as well as Fe3 plus. The Fe2 plus ions occupy the octahedral voids. So 1 out of 4 octahedral voids are occupied by Fe2 plus. And if we talk about Fe3 plus, they are present in the tetrahedral void as well as the octahedral void. So there are 2 of them and 1 is present in the tetrahedral void. So 1 by 8. And the other is present in the octahedral void. So 1 by 4 again. Okay. So if you look at the options given in list 2, only 25% octahedral voids are occupied. So this will not be a match, students. We can clearly see that 2 out of 4 octahedral voids are occupied. So 50% octahedral voids are occupied. So P will be matched with 2. If you talk about the tetrahedral voids, only 12.5 tetrahedral voids are occupied. This is also correct, student. This will be matched with P as 1 out of 8 tetrahedral voids are occupied. So P will be matched with 3 as well. If you talk about the fourth one, coordination number of divalent metal ion is 8 with respect to anion only. So this is incorrect, students. It is present in octahedral void. It means that the coordination number is 6 and not 8. So 4 will not be a match. If you talk about the fifth option, coordination number of divalent metal ion is 6. So this is also correct. This will be matched with P option. So P option, it will be matched with 2, 3, 5. And we can see that the answer is most likely going to be option C. Let us talk about the second compound now, which is CaF2. So in CaF2, we have an FCC in calcium 2 plus ions, and the F minus ions, they occupy all the tetrahedral voids. Okay. So if we look at the entries given in list 2, so 1, 2 and 3 will not be a match. 100% tetrahedral voids are occupied by F minus ions. If you talk about the fourth option, coordination number of divalent metal ion is 8 with respect to anion only. So this is correct, students. Fluoride ions which are present in all the tetrahedral voids surrounding the divalent cation. Okay. So fourth will be a match with Q. If we talk about the R option now, BaTiO3, it has the perovskite structure. So if we talk about this perovskite structure, students, we can probably have a diagram. Students, in the perovskite structure, the barium 2 plus ions forms a simple cubic. So there will be barium present at all the corners. So we have barium 2 plus in green, which are present at all the corners. The oxide ions are present at all the face centers. So we have the oxide ions at all face centers. And if we talk about the Ti3 plus, the Ti3 plus is present at the body center, students. So this is the perovskite structure, students. If you look at the options given in list 2 now, if you look at option 1, only 25% octahedral voids are occupied. So if we look at the crystal very carefully, students, we can see that if barium 2 plus and oxide ions are considered, they seem to be forming a pseudo FCC structure. So in the FCC structure, all of these atoms have to be the same, but in this case, they are not same, hence we are calling it a pseudo FCC structure. So in the pseudo FCC structure, there are octahedral voids present at the body center as well as the H centers. So the H centers are not occupied, whereas the void at the body center is occupied. So we can clearly see that it has a coordination number equal to 6. It is in contact with the 6 oxide ions denoted in red. So 1 out of 4 octahedral void is occupied in this case. So 25% octahedral voids are occupied. So 1 will be a match. 2 will not be a match. If we talk about the third option now, tetrahedral voids. So there are no tetrahedral voids which are occupied. If we talk about the fourth one, the coordination number of divalent metal is 8 with respect to anion only. So if we talk about the divalent metal ion, it is present at the corner and it is in contact with all the oxide ions which are present at the phase centers. So it is going to have a coordination number equal to 12 and not 8. So R will not be a match. If we talk about the fifth option now, coordination number of the divalent metal ion is 6. So if we talk about the divalent metal ion, we had already seen that it had a coordination number equal to 12 and not 6. Okay. So it will be matched with only 1. Now if we talk about the last one, which is the MgAl2O4. So students, the MgAl2O4 has a normal spinal structure. So MgAl2O4 is normal spinal. So in the normal spinal structure, the Mg2 plus ions, they occupy the tetrahedral voids. Whereas if we talk about the Al3 plus ions, they occupy octahedral voids. Okay. So the octahedral voids occupied are 2 out of 4, whereas the tetrahedral voids occupied are 1 out of 8. Okay. So if we talk about the percentages now, 25% octahedral voids are occupied. This is incorrect, students. We can clearly see that 50% octahedral voids are occupied. So S will be matched with 2. If we talk about the third option now, only 12.5% tetrahedral voids are occupied. This is correct, students. This will be matched with S as only 1 out of 8 tetrahedral voids are occupied. So 3 will also be a match. If we talk about the fourth option, coordination number of divalent metal ion is 8 with respect to anion only. So this is incorrect, students. It is 4. The divalent metal cation in this case occupies the tetrahedral void and the coordination number in the tetrahedral void is equal to 4. So 4th will not be a match. And if we talk about the last option now, coordination number of divalent metal ion is 6. So this is also incorrect, students. We had already seen that the coordination number of divalent metal ion was equal to 4. So we have the correct matching for this question. So P will be matched with 2, 3 and 5. Q will be matched with 4. R will be matched with 1 and S will be matched with 2, 3, which is given correctly in the C option. So for this question, students, we have to mark the correct answer as option C. So this is it for today, guys. I hope the solutions were clear to you. Thank you.